Welcome to Math Classes by MSR. In this video, I will be discussing with you all nature of the roots of the cubic polynomial. So, nature of the roots of cubic polynomial. Let us consider the polynomial f of x is equals to ax cube plus bx square plus cx plus d, where a is non-zero real number. Here, before going to discuss about the nature of the roots of cubic polynomial, let us discuss what is the nature of the polynomial when a greater than 0. In general, what is its graph when a greater than 0, and what is its behavior when a is less than 0, that is the leading coefficient. So, when x is approaching infinity, f of x approaches positive infinity. When x is approaching negative infinity, f of x approaches negative infinity. This point you should keep it in the mind. So, graph will approach positive infinity when x is approaching positive infinity, and graph approaches negative infinity when x is approaching negative infinity. This is when a is positive. When a is negative, what will happen? If x is approaching positive infinity, f of x approaches negative infinity. X approaches negative infinity, f of x approaches positive infinity. So, it is like this. So, this idea you should have before we start discussing about nature of its roots. So, in this video, we will be discussing this particular nature of the roots of cubic polynomial using differentiation. That is, what is f of x? We have ax cube plus bx square plus cx plus d, where a is non-zero. If you find differentiation, ax cube is 3x square, bx square is 2bx, cx derivative is c, and d is 0. So this is f dash of x. So what is discriminant? Let us discuss. Discriminant is b square minus 4ac, right? So as using that, 4b square minus 4 times of 3a into c, that is 4b square minus 12ac. So that is 4 into b square minus 3ac. So this is discriminant. So based on the value of this discriminant, we are going to discuss the nature of its roots. So before going to discuss about it, what is the meaning of derivative? Let us understand. So to understand the further concept, you should have this idea first of all. If there is any curve, okay, suppose here one point, here it is one point, here it is one point, here it is one point. So at every point on this curve, we can draw one tangent. So this is one tangent. Here also there exists one more tangent. Even here you have one more tangent. Even here you have one more tangent. So at any point on this curve, we can draw the tangent. So slope of this tangent at this point, suppose P, this is Q, this is R, this is S. Okay, slope of this tangent at this point is called derivative at this point. So when I draw a curve like this, if I draw a tangent here, you can say that at this point P, if you draw a tangent, so slope of this tangent is nothing but derivative of this curve at this point. derivative of this curve at this point. Now if we draw a tangent parallel to x-axis, we know that slope concept. If we draw a tangent parallel to x-axis, slope of the tangent is 0. Slope of the tangent is 0. Means if derivative of any function at any point is 0 means slope of the tangent at that particular point is 0. So here you should understand this concept. We are going to use this concept in the problems in this particular concept. So if first case 1, if delta is less than 0, what is the meaning of delta less than 0? For f dash of x, there is no real roots. For f dash of x, no real roots. So if delta less than 0 means f dash of x have no, f dash of x is equals to 0, have no real roots. F dash of x equal to 0 have no real roots. That means for no value of x, f dash of x becomes 0. Means f dash of x is non-zero for every x belongs to R. For every x belongs to R. F dash of x is non-zero for every x belongs to R. That means what is the graph nature? Let us understand. If a greater than 0, we know that graph will be, when x approaches minus infinity, graph will be approaching negative infinity, right? So from this the curve starts, it will keep increasing. Means it is a strictly increasing curve you will get. Why I will tell you is, if the graph bends like this, at this point, if you draw a tangent, the slope of the tangent becomes 0. Means slope of the tangent is becoming 0 means f dash of x is becoming 0. That means for f dash of x there will be a real root. So, but as per the condition delta less than 0, what we consider, f dash of x should not have any 0. Therefore, this graph, this curve goes keep on increasing. So, curve you will get strictly increasing. Okay, strictly increasing curve you will be getting. Therefore, this curve intersects x-axis at only one point. That means f of x will have only one real root. Will have only one real root. So when f of x is one cubic polynomial and its derivative 3ax square plus 2bx plus c have no real roots, then f of x will have only one real root. Even a greater than 0 like this graph, if you take a less than 0, the graph will keep on decreases. Here you will get strictly decreasing graph. Means you should understand that condition 1, when delta less than 0, f of x will have only one real root. Now comes to the condition 2. Delta is equals to 0. Delta is equal to 0. Means if delta equals to 0, what will happen? F dash of x can be written as delta equal to 0 means what? F dash of x equal to 0. For this delta is 0. Means roots are real and equal, right? Means f dash of x will have two real roots or not, let us say, and both are equal. So let us say x minus alpha into x minus alpha, that is a into x minus alpha whole square. A into x minus alpha whole square. This is f dash of x. This is f dash of x. F dash of x is equals to a into x minus alpha whole square. Now I got f dash of x. How will I get f of x? Just antiderivative, that is integration that is a into integral of x minus alpha whole square dx, that is a into x minus alpha whole cube by 3 plus some k integrated constant. Now in this is f of x we got. If k is equals to 0, if k is equals to 0, 3 equal real roots we will get. So f of x will have 3 equal real roots. If k is equals to 0, f of x will have 3 equal real roots. If k is non-zero, then f of x can be written as a into x minus alpha whole cube plus 3 plus k will have at least one real root. At least one real root will have when k is non-zero. For some value of k or for some value of alpha, f of x becomes 0. So at least one real root will have. So all the 3 complex roots not possible. All the 3 complex roots not possible. All 3 can be real. So always complex roots occurs in pairs. So that means that therefore at least one real root will exist. So this is case 2. When delta is equal to 0, you will have either 3 equal roots or at least one real root based on the value of k. Let us go to the next condition. So we discussed starting delta less than 0 will have exactly one real root. Delta equals to 0 will have either 3 equal roots or at least one real root based on that given condition. Now case third case, when delta is greater than 0. Delta is greater than 0, what will happen? When delta greater than 0 means f dash of x equals to 0 have two distinct real roots. Two distinct real roots. That means let us say two distinct real roots. So I can write f dash of x is equals to a into x minus alpha into x minus beta. A into x minus alpha into x minus beta. So now what I will do is, in this the case 1, f of alpha into f of beta less than 0, what will happen? F of alpha into f of beta less than 0. You should remember that alpha and beta are the roots of f dash of x equal to 0, not f of x equal to 0. Alpha and beta are roots of f dash of x equals to 0. Means f dash of x is 0 at x is equals to alpha, f dash of x is 0 at x is equals to beta. This point means curve must have at 2 points, curve there should be 2 turns, at least 2 turns should be there on the curve. So at alpha there should be 1 turn and at beta at 1 turn, because at this point if you draw the tangent, slope of the tangent is 0, means that is nothing but f dash of x is 0. So based on this idea you should have before understanding this. So if you take f of alpha and f of beta, product is greater than less than 0, means one of them positive, other one is negative. So as we know that a greater than 0 case, if you take, curve starts from this, because f of x approaches negative infinity when x is approaching negative infinity. So from here it will start and it will go, if you take alpha here, beta here, f of alpha is positive, so I am bringing up, and at alpha there should be a turn because f dash of alpha is 0, because alpha is the root of f dash of x equals to 0. Means here one tangent should come which is parallel to x axis. Again f of alpha is negative, so it should come down. Again there should be a turn at beta. So here also f of f dash of alpha is 0. Okay, so now as x approaching positive infinity, f of x approaches positive infinity. So it will go like this. Means attending to how many points it is intersecting? It is intersecting at 3 points. Curve intersecting the x-axis at 3 points. Means in this case you will have 3 real and distinct roots. 3 real and distinct roots. Even you can take need not be f of beta greater than 0, f of alpha less than 0. You may get same condition. You will get same condition. This is one. When f of alpha and f of beta less than 0, 3 real and distinct roots. Second case, f of alpha into f of beta is equals to 0. F of alpha into f of beta equal to 0 means f of alpha is 0. First case. Second case I will take f of beta is 0. If f of alpha is 0, so again minus infinity plus infinity here. I can draw the graph like this. So f of alpha is 0 means we are taking f dash of x is 0 means f dash of alpha is 0 as well as f of alpha also 0. Alpha is the root of even the f of x. So that means it will touch the x-axis at one point and it will go, and this is alpha, suppose there exists beta. So at beta also you should take the turning, because at f beta is the root of f dash of x equal to 0. That means there will be a parallel tangent to x-axis at beta. So that means again it will go to positive infinity. That means here also you will have 3 real roots in which one is repeated root, multiple root. So that means roots are here alpha and one more, say suppose gamma, alpha. Same way the other case also will come. So here also how many roots we are getting? 3 real roots. One is repeated root, other one is distinct root from the two repeated roots. So next case is f of alpha into f of beta greater than 0. What will happen? A greater than 0, if you take, graph will go like this. Now f of alpha and f of beta greater than 0 means either f of alpha, f of beta greater than 0 or both are less than 0. In both cases, let us see. F of alpha positive means curve at alpha it is positive, and also at alpha you should take the turn because alpha is the root of f dash of x equals to 0, and f of beta, somewhere beta is here. Again you should take the curve, you should take the turning at the beta also, because f dash of beta is 0. Alpha beta are the roots of f dash of x equal to 0. Means the curve will go like this. It will go and it will go to positive infinity where x tends to positive infinity. So now the curve is intersecting the x-axis at only one point. Curve is intersecting x-axis at only one point. Okay, so in this you should have idea on this. When f of alpha and f of beta greater than 0, curve intersecting at only one point means only one real root. F of x will have only one real root. This is the concept of nature of the roots of cubic polynomial. In the next video, let us discuss problems on this concept. I hope you understood. Once quickly revise it. See, f of x equal to 0 is a polynomial equation. Let us find f dash of x equal to 0. And then for this you find the discriminant. If discriminant is less than 0, you should remember that only one real root. If discriminant is equals to 0, there are two cases: 3 equal roots or at least one real root. And delta greater than 0, there are three cases: f of alpha into f of beta, where alpha and beta are roots of f dash of x equal to 0, two distinct roots. F of alpha into f of beta less than 0 means three distinct real roots. F of alpha into f of beta equal to 0 will have three real roots, alpha, alpha, gamma, like that. Means one is repeated root, the third one is distinct from this. And f of alpha into f of beta greater than 0. F of alpha into f of beta greater than 0 will have only one real root. So this is in short you need to remember. Okay, that's all. Thank you.